to look at interference in one dimension, let's say that I have a speaker located at the origin. And I know that the speaker is giving off waves of a particular wavelength, horribly drawn as that is there. Now, if I were to add in a second speaker somewhere else, then I could use some of the work that I've done before. Theoretically, this could be as open-ended a problem as I wish. If I were to give you another, if I were to say, okay, these have the same frequency and therefore the same angular frequency, so that a point that hears constructive interference, where the two waves are working together, would always hear constructive interference. And if we were to say these two waves had the same amplitude, so constructive interference will give me twice the amplitude, and perfect, completely destructive interference would give me 0 instead of simply a lower value, to make the concept more straightforward. Then I could work out some system where I had, if I just say, okay, here, they're separated by some distance d. Is there interference out where I can listen to both of them on this one-dimensional axis? Is that constructive, destructive, or completely destructive? Well, that depends on that separation and the phase difference between them. If they're separated, actually, that would require them to be out of phase. So if I were just to say, they're separated by some integral number of wavelengths, then by the time this wave passes the first speaker, the green wave and the blue wave, as I've drawn it here, will be, hey, in phase with each other. And therefore there'll be constructive interference. If I have some case where this is some integer, 0, 1, 2, 3, 4, 5, whatever, plus half a wavelength. So if the difference between them is half a wavelength, then this will be completely destructive interference.